welcome to AWS On Air.
I told you, I'm excited about this.
We want to help you see the things that are new and launching.
We are throwing you into the deep end.
Day 10. Let's do it.
Hey everybody, welcome to AWS On Air, another episode in 2026. I am one of your hosts, Todd Fortier, and if this is your first time ever watching AWS On Air, this is a launch show. We talk about the latest and greatest at AWS, brought to you by the experts who actually help build them. So we want to hear some of your best questions in the chat. And if you're just joining us, we want to know where you're coming from, where you're listening from. But I'm also joined by my good friend and co-host, Jeff. Jeff, we've done a few episodes recently.
Yeah, I think it's a good thing. I know maybe that's part of the feedback. We can ask the audience. Do you guys like seeing Jeff and Todd together? But yeah, I enjoy it. So, hey, everyone. My name is Jeff Marushak. I'm a senior solutions architect on our DoD Air Force team. So helping the Air Force with cloud computing. But also in my spare time, I help host the AWS On Air show with Todd. So thank you for spending your some time of your Friday with us. I always say this on the West Coast, it's about lunchtime. So is there a better way to spend your lunch hour kind of learning about what Todd mentioned, kind of latest and greatest kind of releases in AWS. But then for us, me and Todd, we're Pittsburgh, Ohio area, Cleveland area. It's kind of like the end of the day, the end of the week. And so what better way to kind of finish out your week with spending an hour with us and hearing stuff, seeing some really cool demos. So that's what we're about. And we thank you for joining us. And we would love to see where you're tuning in from.
Best part of the week for me, per usual. For some reason, I'm a little nervous today. I don't know what it is. My heart's pounding a little bit. I don't know if it's because it's Valentine's Day tomorrow. A friendly reminder, if you haven't gotten something, which I have not yet done, I'm notoriously bad at, as my wife will attest. Get something for your sweetheart. Happy Valentine's Day, everybody. But today's a very exciting episode. We're talking about some cool topics. Kubernetes, always a really hot topic. So if you're familiar with Kubernetes, we're going to be getting into it a little bit, some things there on EKS, but also a really interesting topic that I've been starting to just hear more about and get more involved in, which is robotics and AI, physical AI. You've heard different used it described in different terms, but we're going to get into that today. So I think it's going to be a fun episode. Jeff, anything you're looking forward to?
Yeah, I mean, I think we've kind of talked through on the show a bunch of times the kind of progression that AI has done in the last like 3 years. And is 2026, 27 the span of physical AI? So I think we're going to learn a little bit about that today. So really excited about that. And it seems like we're always talking about AWS services try to make our customers' lives easier. And we're going to hear about, EKS. And typically when folks first hear the word Kubernetes, it's usually followed with, it's kind of a bear. It's kind of, kind of hard to set up and everything. But it seems like we're going to learn about something that's going to make that a little bit easier. So that's always great to hear about.
Yeah, that's right. It looks like, we got to get this chat alive. Last minute gift for a special someone in your life. You've got you covered. Nothing says I love you like the very own AWS account thing. Yeah, definitely don't gift an for Valentine's Day. That might disappoint some folks, but what do I know?
Yes. Yeah,
well, it's something you mentioned that just got me thinking. Like this idea that AI is starting to pervade these different domains and all these different aspects, and certainly physical AI is one of those ones. The edge AI at the edge, and learning how to do that well. And how to maybe simulate some things and learn some things. That's what we're going to be talking about today. So I'm excited to kind of jump in and figure out how do we start to model some of this stuff before it hits the real world, so we don't have any, errant robots. We've all seen the movies.
Yeah, I mean, we all hear things about using AI to summarize something or to pick out some key points in a document. But this is going to be using AI to train a robot, not program a robot. The robot already, and this is what I think. The robot knows how to move, but we need to teach it to do things. And so I think that's where we're going to learn some cool stuff.
Yeah, very cool. Hey, if you're listening to us and you're here in the chat, let's say hi. We want to say hi to you. Get a chance to queue up some questions. Let us know what you're doing for Valentine's Day. Whatever you want, drop it in the chat, and we're gonna try to read it here on air.
Todd,
Jeff,
I have a suggestion of maybe why you're nervous this week.
what is it?
Well, we live in the same area and in the country, and I just think that your blood is so thick from that month-long like sub freeze, and you're always outside with your animals. I just think your body's adjusting to above freezing temperatures. What do you think?
Maybe, and I think it maybe jumped the gun and aspirationally trimmed my hair and hope for warmer weather. But it hasn't quite happened yet, and so yeah, there's still a bit of a chill in my bones. Maybe you're right.
All right.
But hey, should we get into it, Jeff? Should we bring on our first guest and just get right into, I believe first we got Kubernetes.
Yeah,
Nick,
let's talk about EKS, Kubernetes, and let's bring in our first guest, Sriram.
And just appear.
Wow,
there he is.
Sriram, how are you, man?
How are you guys?
Really
hey,
good.
Sriram,
Why don't you tell our listeners who you are, what you do, and we'll start there.
Sure. Hey everyone, I'm Sriram Ranganathan. I'm a product manager with the Amazon EKS team. Happy to be here to talk about what's exciting with EKS and how we have simplified some of the developer experiences over the last few months.
Simplification, that's a theme we like here on the show, making it easier, especially in the Kubernetes space. For me personally, as a developer, Kubernetes has been something that seems a bit kind of scary, like Jeff mentioned in the intro here. Like, there's a lot to learn, and so it's kind of like this great platform that can do all of these things, but sometimes that optionality can get a little confusing. Maybe, Sriram, let's start. Where do folks kind of get tripped up in Kubernetes from your experience?
Sure, I can talk about that. So historically, EKS has made it very easy to create and manage Kubernetes clusters. But we often feel, and when we talk to customers, that when they start deploying their workloads, building and scaling with Kubernetes, especially from a workload perspective, can be really challenging. And our focus over the last few months has been how do we simplify that experience? And that's where we recently launched a feature at re:Invent called as EKS capabilities, which is primarily aimed at simplifying that experience. How do you get your workloads onto the Kubernetes cluster once you have the Kubernetes cluster? So it's all about the workloads and the workload management.
Got it. Hey, here we are talking about how cold we are, Jeff, and we've got folks joining us from Canada. Hi, Jaspreet, work 65 from Canada. Forgive us for complaining about the cold, please.
So Sriram, why don't you kind of add to your picture there? So before this this feature that you're launching right now and you're going to describe to us, before this came out, kind of walk us through what someone, maybe they're just deploying a workload to EKS, what they would have to be in charge of, maybe like, what was the first step? What did EKS in general make easier? But then tell us, what did they still have to do that this new thing's going to help them with?
Sounds good. Yeah. So let's talk about it. So typically, let's take the example of you have a web application that you want to deploy. A web application can be a simple web application, which is just a bunch of static pages, or it can be an interactive web application, which might have a backend database and other things. Typically, you will have a Kubernetes cluster. And let's say, for example, you want to deploy this particular web application. How do you go about deploying it? You will first look at all the infrastructure resources that this web app might need. Let's say, for example, it needs a DynamoDB backend, or it needs an Elasticache or a CloudFront. You deploy that using something like a Terraform. You provision the infrastructure portion of it. And then now we have to worry about deploying the Kubernetes manifest, which is the deployment, the ingress, the config maps, and the service. So you use two different tools, one for spinning up your infrastructure and another set for deploying your Kubernetes workloads. So this creates like different experiences because you are doing this in two steps, one for infrastructure provisioning and one for Kubernetes workload management. What we did at re:Invent this year is we launched something called as EKS capabilities, which basically provides three critical platform capabilities for deploying and managing your workloads. So one is continuous deployment based on Argo CD, which is a GitOps-based tool. So you basically declare your state of truth in GitHub, and then let Argo CD work its magic to make sure the actual state in the cluster reflects it. So you are always interacting with GitHub and let Argo CD manage it for you. The other thing which we introduced is something called as managed AWS controllers for Kubernetes and Kube resource orchestrators. What these do is, I'll first start with AWS controllers for Kubernetes. If you remember, like we used to have two different steps previously to basically install your infrastructure resources and then your Kubernetes resource. With AWS controllers for Kubernetes, it allows you to provision your cloud resources in a Kubernetes native way alongside your application manifest. So you don't have to now have this two-step process to basically provision all of your infrastructure. Kube resource orchestrator is a nice addition on top of that. If you think about it, Kubernetes manifest can get really complex. You have like multiple different AWS resources. You have DynamoDB table, you have a role, you have a policy, and then you have various Kubernetes objects. How do you create simplified abstractions on top of it? So everybody in your organization does not need to know what a web app is made up of. All they probably care about is need to know what is the name of the web app, in which region it should get deployed, how many resources I need to have, and probably whether it needs a backend database or not. That's what probably developers care about. So the platform team or senior developers can go ahead and create this template using Kube Resource Orchestrator, which then allows developers to just create instances out of it, and it will do the magic of automatically spinning up all the required Kubernetes resources for you. So those are the three distinct capabilities that we launched.
Yeah, perfectly. I mean, it makes perfect sense. The thing about Kubernetes, the Kubernetes itself is a powerful platform in and of itself, but the tooling that you can use to manage it are just as powerful. And it seems like there's all these different tool sets that help me make it easier. What I hear you talking about is like instantiating a template so that it's repeatable and scalable and it's easier for the people. We launched this thing called capabilities to address that. But but these tools aren't new, right? So how were they used before capabilities existed?
Sure, yeah. These tools are not new. These tools are open source tools, which many of our Kubernetes customers and EKS customers have been using for multiple years. But the thing is, when you think about it, there are like each tool has its own specialization in terms of what it can do. When you need to manage it themselves, people were just installing open source version of it, and then they will have to worry about the patching of it, the upgrading, the auto scaling. And when you think about expanding this to multiple different Kubernetes clusters across different regions at scale, the amount of operations that you have to do really becomes unmanageable. So EKS capabilities is aimed at simplifying all of that. This is a fully managed version, so you don't have to worry about the provisioning of additional resources in case you need to auto scale it. You don't have to worry about patching it. You don't have to worry about upgrading it. And the best part is it's not even running on your cluster. You just tell that I want this cluster to have this capability. All of those capabilities are hosted within AWS own service accounts. So we manage it completely for you. So it's not consuming resources on your cluster, removing all of the undifferentiated heavy lift.
Yeah, Shriram, to take your point one step further, you mentioned, scaling of people kind of using, deciding to use this tool. Maybe another group uses a different tool, and then this group uses a third tool that kind of does the same thing. It's open source, and now you have your whole enterprise, people using different things, and devs moving back and forth, having to learn what's going on. And so this seems like a way to keep everything together. So, Shriram, sounds like you have a demo for us. Can we see some of this in action?
Sure. Let me go ahead and share my screen. Let me know when you guys can see my screen.
I see it.
I have two monitors. If I'm not looking at the camera, that's because I'm looking at the screen. Just please pardon.
That's cool. We see the service console,
Perfect,
management console.
So this is the Kubernetes service console. I have like 3 different clusters here. Let's first go about and see how do you go about creating these capabilities. So let me go to the first cluster called as demo EKS capabilities. If you come here, this is the page that you will land when you open any particular cluster. There is a tab called as capabilities. You click on capabilities and you will see all the different capabilities that we launched at reInvent present over here. So let's go ahead and provision these capabilities. The provisioning is pretty simple. You basically select all the capabilities that you need. I'm selecting Argo CD for continuous deployment, AWS controllers for Kubernetes for cloud resource management, and Kube Resource Orchestrator for basically creating abstractions. I click next. All of the information that you need is mostly pre-filled. If you did not have a role, we also have an easy way wherein we will guide you through the role creation process. But this is the capability role which allows the EKS capability to interact with your cluster. So I have the role created. I'm going to keep the endpoint as public. The way Argo CD works is typically in an upstream Argo CD, if you decide, you can manage the users locally. But in this case, for security purpose, we have integrated with AWS IAM Identity Center. So that way it allows you to integrate with your IDP provider. So you can federate to any of your IDP. I have the Identity Center already created, so I'm not going to create one in this demo. Let me go ahead and select that. And I'm going to basically assign the Argo CD related RBAC permissions. In this case, I have created a demo user and I'm going to make them as the admin. I'm creating this mapping depending on your org. You can choose which user should have what kind of privileges. We have some predefined privileges that we have defined, but if you want custom, you can always apply custom rules as well. Similarly, you have for AWS controllers for Kubernetes, there is the name of the capability and a role. I will go ahead and basically create these capabilities.
Yeah, that's neat. So it sounds like you can choose, like pick and choose. You don't have to allow all three. You can let some people have one, and with that federation you just showed, maybe have another group have access to another.
Exactly. That was very important for us when we were working backwards from our customers as part of the PRFAQ process. We wanted to provide maximum flexibility. So if we are not forcing anybody into using all the three capabilities together, you can pick and choose depending on your pace and your use case, whichever you want to use. These are three distinct capabilities. Each one works individually. If you want to pair them together, you can do that as well.
Yeah, so this is this pattern. Like, we still need to configure something. We still need to know something from you, but this has significantly reduced the complexity of setting up any one of these capabilities. Just a few settings, who should have access to it, click go. Now where are we at?
So now the capabilities are getting created. This takes about 2 to 6 minutes depending on the capability. I have another cluster which I have provisioned with all the capabilities ready. So let's not wait on this. So let me switch clusters.
Nice.
So I have another cluster here. We call it as the platform cluster, and there is a spoke prod one cluster. So let me explain the relationship. In the platform cluster, I have the Argo CD capability enabled. The way I'm going to demo is it's going to be in a hub and spoke model. So all of my Argo CD applications are going to get deployed onto the platform cluster, but it's going to actually deploy the web application in the spoke cluster, right? So in this particular cluster, I only have Argo CD enabled. If I go back to the spoke cluster and I go to the capabilities tab, you see I have AWS controllers for Kubernetes and Kubernetes orchestrators enabled. So basically, because my web application is going to spin up cloud resources, I need to make sure that I have ACK enabled on this particular cluster.
Yes, Sriram, we got some folks in the chat that are looking for maybe a reminder of the purpose of each of the capabilities. Maybe Argo CD is for Git ops-based app synchronization to target clusters. Just quickly remind us what capabilities do.
Argo CD is mainly for GitOps-based continuous deployment. So you point it to a Git repo and let it start deploying the applications for you onto a target cluster. AWS controllers for Kubernetes is basically allowing you to manage AWS resources in a Kubernetes native way. Think about an S3 bucket. Think about provisioning CloudFront. Think about provisioning a DynamoDB table. How do you manage it in a Kubernetes native way from the Kubernetes cluster instead of having to use a separate tool? Kuberesource Orchestrator basically allows you to create simple abstractions for your Kubernetes resources. So it allows you to create CRDs at runtime so that you don't have to worry about creating custom controllers and custom CRDs handwritten. It does it everything for you automatically.
Very cool. So we've got this cluster spin up, we've got the capability launched, and then you can see it in this new tab here, capabilities.
So this is a cluster where Argo CD was already installed. You can click on Argo UI, go to Argo UI. We provide a convenient link for you. I already have that open here. So this is, once you launch it and provide your login credentials, this is the page where you will land. I have two applications deployed here. One is an e-commerce app, another one is a task tracker app. I'm going to talk in detail about the task tracker app. If you see here, this app that I created is coming from my GitHub repository, and it is getting pushed to the spoke cluster one. But the Argo CD capability itself is running on the platform cluster, which is the hub cluster. But I'm going to deploy applications to a different target cluster. right?
Okay.
So if I go into this, part of a live demo, let me
We get it.
the page. Okay. So when you click on the application, you would basically see what that particular application is comprised of. So I have a Crow RGD, which is the CRD definition for the web app that I am using. And there is an instance of the app that I have deployed. It consists of the usual suspects of Kubernetes resources. There is a configuration, config map, there is a service, there is a service account, there is a deployment. Additionally, if you see, then we have some custom resources. There is a table, which is not a native Kubernetes resource, but this what actually is doing is it's spinning up a DynamoDB table for you. And then we have an IAM policy and an IAM role. And there are 5 pods that are running for you.
So Argo is this really powerful tool that gives you all these tools at your fingertips to manage Kubernetes. But what's really impressive to me is that you just filled out some basic configuration, click go, and this application's hosted for you. You don't have to think about how you're going to host this application, where to deploy it. You just click the button and you're launched into the console. And now you can start leveraging the capabilities of Argo itself without having to do that. Sriram, we've got just a few more minutes left in the demo. I want to make sure that you get to anything that's really awesome that you want to show. And then I want to hear where folks should go to learn more about what you launched.
Sure, definitely. Let's do that. Yeah. So let me go ahead and quickly deploy a new application to Kubernetes, and let's see how that reflects. So if you see here in the application stack, we only have 2 applications. Let me go ahead and deploy a third application here. It's another instance of the same task tracker app. So if you see, I'm just running a CLI command. I'm applying the application manifest to it. The application got created. Let's switch back to the console. And if you see, the third application is getting deployed now. It's healthy, it's synced up. It does take some time because the AWS resources are getting provisioned. I will not going to wait for that particular one because the load balancers need some time to get provisioned. If you have custom health check, you can make the health signals wait for the actual resources to finish completing, but that's completely up to you to customize. In this particular case, I already have an application deployed, which is the task tracker app. So if I already grabbed and launched this for you for the purpose of this demo, so this is the app that we built. There is a task tracker. So let's say we want to watch Winter Olympics this weekend.
Nice.
Right? We create this task, we add the task here, and the new tasks are created. But where is this getting stored? This is basically going and sitting in a DynamoDB table. If you go to DynamoDB, this DynamoDB was provisioned using ACK resources. So if you go here, go to the Crow tasks. If you see the last one, watch Winter Olympics this weekend. This is the one which we just created.
Yeah.
So this is a new table that is just got provisioned because we deployed the new app. So there, once the load balance is ready, we can grab the URL and we can work with that. So the advantage here is, like, once you have the basic resource definition using Crow installed in the cluster, any number of development teams can come, and without knowing all of the underlying Kubernetes complexities, they can just simply specify, hey, I want a web app with this name in this region. It needs to have a backend with DynamoDB or S3 or whatever, and you can just start simply spinning up the applications that you need.
Yeah, I can imagine a developer who has a lot of experience with creating container applications, but maybe, maybe they were using another cloud provider, or maybe they've never done anything in the cloud. They've done like OpenShift or something on-prem. They don't have to go and learn EKS per se. They can do what you just said and say, I know what an S3 bucket is. I just need that, but I don't want to go learn and make the Terraform and forget a comma and have to troubleshoot why my Terraform isn't working. And then, there's not, maybe a Kubernetes platform team that they have to wait on that team to build the infrastructure for this web app, and the dev's just sitting there waiting for something to build out. So this is really cool.
Yeah. Awesome. Yeah. That's pretty much it. That's what I wanted to demo.
Great, Sriram. Hey, if folks wanted to learn more about capabilities, about EKS, about the capabilities that you launched, where should they go to learn more about that?
Yeah, we have a AWS news blog that I would recommend as a starting point for you. It automatically has pointers to various other references. So I would say start off with the AWS news blog.
Very cool. Hey, go check out the news blog. Go learn about EKS capabilities. Sriram, thank you for being on the show, and can't wait to see what you launch next. We'll have to have you back on the show.
Thank you so much.
Thanks, Sriram. That's pretty
There it is.
cool, man. New services, new features, making things easier for our customers. I love it.
That's what this show's about, Jeff. It's just showing how we are building things that make things easier for customers. And this is a perfect example of working, something that I've always appreciated about working here at AWS, which is this culture of working backwards from customers, taking very seriously the feedback of the people that we work with, and then going and doing something about it, making and launching, and then coming on the show and letting you know about it. And speaking of feedback, Jeff, we take feedback for the show. And we do that primarily through our survey.
Yeah. So earlier on, I kind of asked the audience, do you think me and Todd work well together? Let us know. But do you want to hear more about Kubernetes? Do you want to hear more about AI? Do you want to hear more about security? I didn't like this segment. I didn't like, something. That's what we want to know. So if you see the link on the screen, it's in the chats. Click this for a quick survey to let us know, give us some feedback, because
you need a builder ID to take the survey. But if you don't already have a builder ID, what have you been doing? Like, get a builder ID, go take the survey. The builder ID gives you access to all kinds of other things here at AWS. But take the survey. Like I said, we take this very seriously. We work backwards from the feedback, and we want to make sure that we're incorporating your feedback in the show as we move forward. So thanks, Jeff. Jeff, we got more. Actually,
yeah. Well, some of the feedback I've been hearing is that people love the Jeff Barr segment.
I think that's right. And I think we don't always get to have Jeff Barr on the show, but the times that we do have Mr. Jeff Barr on the show are
grateful. We're grateful.
Great. So maybe I can convince Jeff to be my Valentine. Should we bring him on?
Yes, let's do it. Jeff Barr, welcome to the show.
The Eagle has landed.
Hey, Todd. Hey, Jeff.
Hey,
Good to see you both.
Likewise, Jeff. Happy Valentine's Day.
Yeah, likewise. I'm already married. Otherwise, you'd definitely be my Valentine.
Me too, but maybe there's some form of professional Valentines. I don't know.
Yeah, exactly. Office Valentines.
So, Jeff, what is that? The red thing that looks like a console from the Enterprise in the first season of Star Trek in the background.
This is a 3/4 scale replica of a PDP-11 mini computer from the 1970s, and it's super cool because it was one of the computers I used early in my programming career, and also I like to have blinking lights and LEDs around me wherever possible.
Same.
The more, the better.
Likewise. I'm a fan of blinking lights.
Better. LEDs are the coolest things.
Looks really cool. So what's new this week? You always share a bunch of cool new things, and a lot of times you share interesting things that maybe aren't like on the headlines, that maybe get looked over, but when the way you explain them, we're like, how come this isn't bigger news? So I'm always excited to hear which ones you pick out.
Yeah, exactly. So I got 3 awesome things this week, and the first one. So at the end of 2024, we launched this thing called AWS Data Transfer Terminal, and I'm not sure this actually caught people's eye because it was part of a massive pile of reInvent and pre-reInvent launches. So for a long time, we've been trying to provide our customers with ways to get lots of data up to the cloud. And in many days past, we had this thing where you could actually like ship us discs and tapes. We did that for a while. We had snowmobile devices, and we had the snowball devices, all those kinds of things. But the data transfer terminal is actually a really cool thing because it's not quite a thing, it's a place. So we launched with 2 locations in Los Angeles and New York in end of 2024. And the idea is that you go to the console. Now one thing I learned today is your account has to be what we call an AWS Enterprise account right now to use this. So you, assuming that you are an AWS Enterprise customer, you go to the console, you find a location near you, and then you pick an open time, and then you show up at this secure location. You bring your data with you, like you bring your minivan or your car or your truck full of data on some kind of an actual device you can plug into a network. And I actually haven't been to one of these yet. I'm actually hoping to get to see one firsthand soon. You show up and you plug into a high-speed direct upload connection to AWS. Apparently, some of them can go like to 400 gigabits. And And so you can then directly upload to S3 or EFS, like probably at more bandwidth than you might be able to do from your corporate network.
Sure.
So like you've got a bunch of stuff and you want to get to AWS as expeditiously as possible. The data transfer terminal, and so the news today, we initially launched in Los Angeles and New York. After that, we added Munich, Germany, and then San Francisco. I actually was in San Francisco this week, didn't get to see the terminal. But this time around, we added 6 more locations. We added Seattle and Phoenix in the US. We added London and Paris. We added Sydney, Australia, and Tokyo. So now our customers have, is that 6, 7, 8, 10 locations. 10 locations, kind of nice international flair, kind of like the Olympics, to our data transfer terminals. So hopefully more local and more convenient to our customers than ever. Kind of like bobsledding, and that there's a bit of prep, a lot of practice. You show up at the top of the hill with your data, and then zoom, it goes really, really, really fast up the cloud. So that was my best analogy I could come up with.
This is a perfect example of what Jeff M was describing at the beginning. I had never heard about this. I missed this launch completely. And I have so many questions now about terminals. And I mean, it makes perfect sense that you might have this big of a pipe at your office, but you get access to the real deal if you go show up to a terminal. That's amazing.
Yeah, and what you just described, I was picturing like you see in the movies when people go into the room to open up their safe deposit box. Like I pictured that, except for someone bringing in like a mainframe tape silo with the robot. And they're like trying to like, here we have 1,000 tapes we need to do. So that'd be cool. So, but yeah, very interesting and neat to hear people thinking outside of the box. Like, yeah, let's make it a cafe and have people come here and bring their data here when it makes sense, because I'm sure there are times when it does make sense and times where it doesn't. So
yeah, apparently we have a question from Jessica asking about we don't have Detroit yet, but we're going to continue to, of course, listen to our customers, add new locations. Seattle is not that far from Detroit, so feel free to come on over with your data, bring your data.
And you said the requirement is to be the requirement is still you have to have an enterprise account on AWS.
Yeah, I'm actually messaging with the team to see if we can clarify that a bit. But right now, an enterprise account. But I'm sure if you've got a lot of data and you're not quite enterprise, talk to one of us and we'll figure out a way to help make that happen.
Very cool.
Yeah, so I think that's super, super, super cool. Did we share the link to the what's new? We didn't.
I think we did.
Maybe Nick will do that. If Nick wakes up, then we'll share the link to the what's new. Okay, next cool thing. Okay, so you guys know when you use security groups, you can use them in a lot of different contexts across your AWS setup. And sometimes when you have a security group, the question comes to mind like, where am I using this? And if I make a change to the security group, just exactly what are all the things that are making use of the security group? And that was actually kind of hard before. You had to like open up a gazillion tabs in the console and click, and look and think. And it was kind of like actually like mental gymnastics to do all that stuff. So you're trying to do all this stuff. And now we have this awesome thing where you can open up a security group in the console, either in the EC2 or the VPC console. When you see a security group and it shows you the extra detail at the bottom, there's now a tab that says related resources. And so when you click on the tab, it pings in real time other parts of other services and says, hey, are you using this security group? Are you using it? Are you using it? And then it shows you the other, not all yet, but apparently we're still expanding this, but it shows you if your EC2 instances, your ENIs, your Elastic Cache clusters, your RDS databases, it shows you if they're actually making use of that security group. So you can feel more confident as you are either making changes to the group or you're going through and you see like security group XYZ 9991123 test created by Todd. And you're like, did Todd actually mean this was for production, or was it just like a random test last year he forgot about? You can actually see, hey, am I using this or not? And then feel more confident either changing it or deleting it. So I like that one a bunch.
This is like, yeah, this is, or you maybe have a policy in your organization where if you turn something on, it's going to, and you're trying to figure out, I've been in this position where I'm debugging, what thing is using this security group that is flagging this alert that I'm trying to debug it. It's kind of like face planting on the downhill ski. It's like, I don't want to be that person.
Exactly. And so when you actually do this in the console, it's not like pre-computed or pulling off of a database. You can, when you click on it, you can actually see all the queries being kind of like
Real time.
farmed out to a bunch of different services. Now, I would caveat this a tiny bit by saying some of the more obscure places you can use security groups, it doesn't check those yet. But given that they're listed in the console as not yet supported, my assumption is that we'll just, like a lot of stuff, we launch it with a strong initial footprint, and then we're like, okay, we can make this even better. There's more stuff we need to actually add in as we go. But certainly we caught a lot of the most common places where we're going to use security groups. So really like that. Again, no mental, no physical gymnastics to do that one. And less jumping through hoops. Is jumping through hoops an Olympic sport? I don't know. What would you call that?
It is at my house.
Yeah. All right. Do we have time for one more?
I think so. Yeah, let's do it.
Yeah.
Yeah. All right. So in the alphabet soup of EC2 instance names, the newest ones are M8AZN. So these are really new and super powerful instances. They've got high-speed 5th generation AMD EPYC processors. They're up to 24% better performance than the M8As. Now, the last ones in the ZN line, I guess you could say, have to go back a bit to M5. So if we compare M5ZN to M8AZN, we've got 4.3 times more memory bandwidth, 10x more L3 cache, twice the networking throughput, and up to 3 times the EBS throughput. So the Z is for the high speed, the A is for the AMD EPYC, and the N is for the extra beefy networking. Real-time financial analytics, HPC, high-frequency trading, CI/CD, and simulation are some kind of awesome use cases. 9 sizes, 2 to 96 vCPUs, up to 384 gigabytes of memory, and across 4 AWS regions. So there you go for all your weightlifting needs.
Jeff, you want to talk about Olympic sports? I think naming EC2 instances. I actually just had a thought. At reInvent next year, we should have like an EC2 spelling bee, where like how many letters of EC2 instances can you, like, you get the description, or maybe like a Jeopardy category or something. You just get the answer to what the thing does, and then you have to try to name the acronym.
Or no, maybe you see the instance and you have to correctly break down each letter like Jeff just did.
Yeah.
I like it.
And then you have to say, is it real or not? Yeah, exactly.
Oh,
is
yeah.
Is it real or just a bunch of letters? Now, one thing we haven't done, and I sure hope we don't get this desperate, like imagine if AZN was different than ZNA.
Ugh.
Right?
My head's already hurting. But I think that the headline for me here is like there are so many different computational needs, and it sounds like this is probably another one of those things, responding to customers' requests. Hey, we have this need for this type of computing, and can you support that? And we say, yeah, we can support that, and we launch this EC2 type, and then the benefit is to everybody else who might have a similar use case. And so more. And I think we even talked about before in previous launches, there are tools that help you decide what EC2 instance you should be using. Yeah. And so that might be helpful in this case as well.
Well, I mean, we're kind of joking. We're not making fun of this. I think we're kind of saying it's kind of ridiculous how much choice we're giving our customers. Like, there's a choice for this, there's a choice for that, and even these high-speed financial transactions, everything. And so it's like, it's kind of old hat to us because we see these new instances all the time, but it's just, I just love offering all that choice. And, it seems like every year, just like Jeff said, gets a little bit cheaper and more performance. So, I mean, we're joking because this is so cool.
So to me, another thing is like, you think of some big complex suite of applications. Maybe you're corporate and you've got a data center, and your company has like a deal with some vendor, and so you've got hundreds or thousands of servers from some vendor, and they're all probably either the same spec or a couple generations of the same basic kind of set spec. But you've got that one application that doesn't actually fit the mold. And going to your data center operator and saying, "Oh, I know we have thousands of these XYZ brand whatevers with this configuration.
Yep.
I'm really special and I need AMD EPYC processors and lots of bandwidth and lots of memory and lots of I/O throughput, they're going to say, "Sorry, dude, who are you? We're not super excited about this. Like this is our brand, this is our vendor. We can't help you."
Yeah.
But here you just say, "Well, just pick it off the list and click go, and away you go, and you're up and running."
Anyone who's been involved with corporate IT knows that decisions are made, and then all of a sudden, for example, we're going to use this database, and then no matter what kind of database need, if it's just a note card database, we're going to use this high-end enterprise database because we have a someone 10 years ago decided this is our kind of database. And
hang on just one sec. I need to grab something for Adrian.
All right, cool. So yeah,
all right.
We could see this with compute is the same thing. So we have all these like, no, we are an AMD shop. We are an Intel shop.
Exactly.
We need something else.
I see Adrian was talking about my Lego minifig. So here's another one I 3D printed. This one's super,
Whoa.
super cool. Here, let me zoom out a bit so we can see this one a bit better. But yeah, there we go. How about that? Cool enough?
Yeah, that's cool. Yeah, this looks nice.
Nice.
I tell you, I never get tired of pushing buttons on my Stream Deck.
I know.
All right,
I just got one, Jeff. I'm gonna have to hit you up later about some tips and tricks because I just got one. I'm still figuring out. It mostly it's just a paperweight on my desk right now, but I really need to get involved in it. But Jeff, hey, thanks for coming on. I think that's all the time we have. Any parting wisdom or thoughts?
Go for the gold.
I love it. Go for the gold.
Awesome.
Yeah, go for
Have
the
a good
gold,
weekend,
man.
everyone.
Yeah, we'll
Thanks,
see you next
Jeff.
time.
Awesome.
All right, interesting as always, and we're getting ready for our last segment. And we talked a little bit about EKS, making things easier for Kubernetes, and now we're going to talk about AI, but something I think is going to be new and fresh for everyone: physical AI. Todd, what do you think?
Yeah, actually, this is something I'm eager to learn about. This is like a relatively new category for me too, so bear with me as I fumble through these questions. But we've got the experts coming on next. Nick, bring them on. Slide them into the screen.
There's Judith and there's Mahesh. Hey, folks, how are you today?
Hey, good.
Hey, welcome to the show. Hey, maybe let's start with talking about who you are and what do you do at AWS. Mahesh, maybe I see you first on my screen. Let's start with you.
Yeah, so I'm from AWS ProServe India. So I usually work with customers on migrating and modernizing their applications onto cloud, and I have an AML and DevOps competency also. Yeah.
And fun fact, Mahesh, you're located somewhere a little bit different. You are waking up pretty early to be a part of our show. Where are you joining us from?
Yeah, I'm from Hyderabad, India. It's 2 a.m. for me. Yeah.
2 o'clock in the morning. That's dedication to the craft, Mahesh. Thank you so much.
I'm going to have to change my opening spiel. I always talk about East and West Coast of the United States, and we're like, for our friends in India, it's 2:30 in the morning for the folks. But Mahesh, thank you for joining us.
Yeah.
And Judith, hey, welcome to the show. Again, Judith, this is not the first time you've been on the show. You're a repeat customer here. But remind folks who you are and what do you do at AWS?
Sure. I'm Judith Joseph. I'm a Principal Solutions Architect for AWS. I work with the AWS Solutions org, mostly curating and working with solutions and guidance in Gen AI and physical AI domains. Glad to be here.
So I know a lot of folks in the last 12 months have been using generative AI chatbots. And I know personally myself, I've been using it to learn. I think it's really helps me learn things. But it sounds like you're going to be talking to us about having robots learn with AI. Can you kind of set the stage and explain that for us and our listeners?
Sure. Yeah. So in my past life, until a few years ago, before I joined AWS, I was an electrical and robotics engineer. So working with industrial robots in different industries, right? Like the pick and place robots performing very particular tasks, specific tasks and manipulation tasks and so on. And if anyone who has experience working with these industrial robots, right, we usually program the robot to say, oh, go to these coordinates, X, Y, Z, perform this task. And it's very simple, but it takes a lot of time to dial in the robot to perform that action while commissioning the robot. And anything minor changes, right? Like, for example, anything in the environment or the materials that the robot is manipulating changes. There there are faults that occur, and now you have to have your system integrators or your engineers work on teaching the robot again, like literally with the teach pendant. It is, think of it like a PS4 controller, but it is more rugged, and the industrial robots have a teach pendant that you teach again. Okay, that is all well and done. This is until the robot falls again because something changed. Right? We don't want to be in this endless loop of actively teaching the robot because it is unable to adapt to the environment. So this is what got us thinking about how do we use all that we have right now, right? Like we have different generative AI foundation models. We have AI models, machine learning models, deep learning models. How do we use them to make our task of teaching the robot and then making them capable of learning and adapting on their own easier? So that is why we worked on a public-facing technical asset. It has architecture diagram and sample code, which customers can deploy in their own AWS account and get it up and running and work with the robot and teach the robot through imitation learning and reinforcement learning. At some point in the chat, the session, probably at the end, we will drop a link to that.
Yeah, I love this. Judith, what I just heard you said was like the tolerances for some of these robots are so tight, and when there is a new variable introduced, that can throw off the whole thing, and then you're programming these edge cases to accommodate these new variables or these new environmental changes, and that can be an endless loop. But thanks to the advent of generative AI and some of the tooling available to us now, the robot can learn. Mahesh, maybe can you help me understand what types of robots are we really talking about here?
Currently in our guidance, we have targeted UR5 robot, so which actually does a specific task, moving T-bar to some specific locations. Let's take an example like in automotive industry. If someone wants to fit a bolt, so they have to place it in a specific position. So how does the robot knows where it has to put it in the correct position? So we are going to train UR5 robot just to move the T-bar to a specific target position, so that we will give the enough information to the robot, to the actual physical robot with that data.
Yeah, based on what you just said, I envision I kind of always see like a car assembly line and like a big arm bringing the windshield and putting it down. It has to know where to put that windshield, and it's glass, so you don't want it to drop it. You don't want it to, hit the frame. It has to be pretty precise to do that.
Yeah.
So, I think that's what I was thinking as you were describing that.
Yeah, you're right. Yes.
Cool. So, Todd?
Yeah, I was ready to get into the tech. I want to understand some of the underlying technology, because when I think folks who have been watching, we've been talking about generative AI. We're a little bit familiar with some of the services that AWS has to offer. But when I looked over this content before, I saw some new things. And so maybe we can get a little bit into the tech. And then I want to see this, because I think this is a really cool demo.
Yeah, we will get you up to speed on the architecture and tech real fast. And then we will go to the cool demo part, and hopefully it works really well. So for the tech stack, what we have is, like Mahesh had described, we took a UR5 robot, and then we have a table and a T-bar. The task that the robot is assigned with is to put the T-bar on the target area. So what we did was we started with imitation learning, that is to teach the robot to mimic human behavior as much as possible. So with imitation learning, we feed the robot a few of the human demonstrations. And that was me with the PS4 controller navigating the robot in the simulation environment to do the task. And I'm not a gamer. I'm not good with gaming consoles. So it took quite a lot of time to teach that robot that particular task. It was 20 minutes the first time. Then I got much better. It was 17 minutes after a couple of hours. So teaching the robot, the robotic model, which the model that we have chosen is the action chunking transformer model. So teaching the robot model on this particular data set. And what we did was something interesting. Usually when you want to train a model, you will collect a large data set, diverse data set, right? So that the robot is able, the model is able to perform well in different conditions. But what we wanted to do was take it one step further, where we set the robot to collect the data on its own. So we wrote a script, and it is an open source script right now, where the robot resets the simulation environment every time it reaches an accuracy of 90%. And you can set the threshold limit yourself. So it starts the simulation. In the simulation environment, there are 2 cameras. It is actively seeing the scene and performing the task. If the accuracy drops from what it was before, it cancels the simulation. If the accuracy is 90%, then it saves the episode, which is like observations to actions and with the camera feed. So the data that it collects conforms to the robot framework, which is a famous framework now, because the data set is captures data in Parquet format, MP4 files, video files, so that we can port this data and train on any environment. And in our case, we have used Trainium, and which Mahesh will talk about more.
I think we've teased the demo enough. I think folks are getting a little antsy to see some of this. So maybe, Mahesh, as you're talking about the Trainium aspects of this, we can bring up the screen and we can start showing a little bit more about what you're talking about.
Yeah. So let me just start with the stack. So we are going to deploy a stack where it creates a VPC to run the EC2 instance, and the IAM and the secrets, where it is going to create the secrets manager and the S3 buckets with IAM roles, which needs to be attached to the EC2 instance. And then the EC2 instance, where actually we are going to simulate the real-time environment, how the robot should be. So it's like we are going to use the NVIDIA ISAC simulation environment, and we are going to install the DCV setup to access the Linux instance in the GUI mode, the way you used to do that RDP in the Windows. Yeah.
One thing I couldn't help but notice is we're actually looking at GitHub. So this is the actual code and the open source model. So all of that tech scrap is described on GitHub. That's freely available today. I imagine we have links for that as well. Okay. Yeah. So we got some basic cloud computing things that you're going to need to launch this into your AWS account. Where do we go from here, Mahesh?
Yeah. Okay. So let me quickly run this.
Ooh, terminal demo, my favorite. I love me a good terminal demo. Looks like we're getting ready to deploy a script here, and imagine this is going to launch all of the.
Okay, so basically it is going to deploy the entire stack, whatever I have mentioned you. So usually when you wanted to simulate any environment, so usually developers will struggle what kind of resources I need to use, how do I set up, and all that stuff. So now we have made this CDK so that it sets up everything in one click, so that you don't need to focus on deploying the infra. You can just start working on the actual environment.
Nice.
Yeah.
So all infrastructure set up for you. I see you had a bootstrap an environment with the CDK. So presumably underlying this is a CDK, if you're familiar with that. Okay, so once the environment's configured, what does that give us the opportunity to do? I'm really anxious to see some simulated robot, if I'm being honest.
Yeah. So let me also show you the CloudFormation stack so that I can just quickly go explain the resources it is going to create. So it started creating the stack. So it is basically a nested stack. So it, as I explained you in the GitHub, so it is going to create the VPC and the IAMs and the secret stack. Once both are done, then it is going to set up the EC2 instance. Actually, EC2 setup is the main part of this solution. So where actually it has to install the Amazon DCV server and also NVIDIA ISAC sim. So it needs so much of time to install. So we have made everything embedded into the user data scripts. So it can install everything in one step.
Yeah, and for our listeners, in case you've never heard of CloudFormation or what these stacks are, this is our AWS's infrastructure as code service, sort of like Terraform, but you can see those nested stacks are, some piece of infrastructure that is like kind of nested inside the main stack. So maybe like all the compute would be nested, all the storage would be nested. I'm making that up, but just so our viewers know what they're looking at here.
Yeah, so basically this is the parent stack. So it is going to create the VPC relatedness stack, and then the IAMs and the secret specific tasks. And
But
then the
Mahesh, you said something that I picked up on that. You said that there's still some third-party libraries or maybe some software that still needs to be installed. So, but you've embedded that as a user script in the EC2 instance. So when the EC2 instance is actually launched, all of those prerequisites are installed on the EC2. Is that did I understand that correctly?
Right, you're right. So basically, Amazon DCV is the one which is usually used to access the Linux instance in the GUI mode, the way we use the remote desktop for the Windows.
Okay.
And that's
So
one thing. And another one is the NVIDIA ISAC sim, so which actually helps you to simulate simulation environment. It actually represents your real-time robotic environment.
okay, so that's the actual simulation environment that gets launched
Yeah.
on top of an EC2.
Yeah.
And then once everything's successfully provisions, I'm going to assume that all that create in progress turns green and it's created. What do we get at the end of this stack creation?
Yeah. So anyway, it is going to take. I think Judith has already
Yeah.
deployed this stack in her account, so she will
Let's
be
go
able
ahead and
to
bring
show
up
that.
Judith's screen
Let me
here.
share my screen. I'll show my screen, and it should be showing you the ISAC sim environment that is running in the EC2 instance.
Got it.
Yep.
And you're accessing this through DCV, right? So
Yes,
you could see it.
accessing it through DCV, and I'm showing the ISAC sim environment right now. And what we have pulled up here is a UR5 robot, the USD scene with a T bar that needs to put the T bar on the T slot. And I had spoken about the data collection part of it, right? So let me go ahead and run that script, and I can walk you through what's happening while the script is running, and I'm actively collecting data. So if you see on my screen, you can see that the robot is moving. It is the pre-trained model, the ACT model, and it is actively collecting data. Now the accuracy is 31.315. It will consistently try to reach that 90% accuracy. If it fails, drops below, it'll reset the simulation environment and start collecting data again, new data. Otherwise, if it is successful, it will save all the data in Parquet format, capture the video so that we can train the model and have a policy, train policy that will consistently reach the 90% every single time with all this data set.
So
this
Judith, just really quick, this is you're kind of simulating what you said you did with a PS4 controller yourself.
Yeah.
So someone doesn't have to
Mm-hmm.
suffer through that. Maybe if they don't know how to use the robot to try to show it, this is what good looks like. You're saying we can use this to have it kind of simulate that and get to that 90%.
Yep. Yeah, exactly. You can see that, in this case, the robot is, this is not reinforcement learning, right? With reinforcement learning, that's another script that we have provided, is it actively gives itself rewards or penalties based on reward weighted regression, which is like a surrogate of PPO. So every step it tests, the model tests if it is taking it closer to the goal or not, and takes actions accordingly. But this is just a data collection script where, like you said, based on my PES, the controller demonstrations, the model is trained on it, and now it is trying to mimic that actions and get the results. So all of this data is stored, and then we store it in S3, this huge data set of all the episodes, and we use Trainium instance to train the model on all this data set. So there is.
So correct me if I'm wrong. So what this is actually doing is seeing how the T-bar moves depending on where it hit it and in what direction. So then it could train it I know I wanted to get it into the T. Now I know how it moves based on where I hit it and from what direction.
Yeah.
You're training it. It can use AI to train to get it right into the T.
Yeah. It is only going by the accuracy. Am I getting near the accuracy point?
Gotcha. Yeah.
And for every 50 steps of the episode data, it is actively invoking the Amazon Nova Pro model. So for those of you who don't know about Amazon Nova Pro, it's a multimodal model. So there are 2 cameras for this robot setup, one on the wrist of the robot, one from overhead. And we are actively sending these scenes to Nova Pro. So just like you and me are seeing this robot performing the action, right? We have Nova Pro, let me see, for every 50 steps. So Nova Pro actively making observations like, oh, the robot is doing this, but I think it should be doing this. So it is like acting like an observer, which is very important data that we can feed back into the loop of the simulation and training.
And probably sure. And obviously this is a very rudimentary example. We're just putting a T and a T bar, but you can kind of envision this, project this out, get a little bit more complex. And I can almost even see like a combination of reinforcement learning, but also this generative AI simulation learning. And then those things collectively just reduce that learning time. And the model gets smarter and smarter and smarter until eventually you've achieved some operational efficiency that it meets your objective. Or, I mean, I'm just kind of like projecting this out in the future and thinking,
Todd, you know what I'm thinking is like how cool it would have been to have this when I got that toy robot arm when I was in 7th grade that we all had. Like how what I could have done with it.
Away with like some like AI.
Yeah, so awesome.
So so I will stop my screen share now, and maybe Mahesh, is there anything else that you would want to cover as part of the demo?
I think we can just explain the high level context. Like so basically it is just focused for only for URFI robot. For this, I think we can for every robot we need to create a USD files to do this kind of operations, and we also have some pre-trained models for every robot so that we can make use of it, and then we can generate the actual episodes for everything for all the robots, and we can use that for the physical robots.
Gotcha.
Nice.
Yeah,
and you said that you've got some pre-trained data, you've got some scripts developed for people, and all this is available open sourced on GitHub. Where should folks go to get that? Do we have I think Nick might have jumped in and dropped the link.
Yes, we can share that the GitHub link and the guidance link, which has the references. Yes.
Yeah.
Yeah, and I wanted to tie it back to something Judith said earlier. Think about like all the pick and sort robots, and like what if they're trained on one product that comes in like a certain cardboard box, but for whatever reason the cardboard box changes material, or maybe it's like a centimeter longer than normal. It sounds like this retraining can be automated, and then even with the use of like IoT services, you can then push that new model out automatically. So this is just all this automation to kind of keep this cycle of keeping the robots trained. It sounds really interesting.
Before you know it, you're setting Olympic records and doing as Jeff said, going for gold. Hey, Mahesh, I want to sincerely thank you for waking up as early as you are in the middle of the night and joining us. Very cool demo, very cool stuff. Judith, thanks again for coming on to the show.
Thank you.
Yeah, thanks.
Thanks, everyone.
Thanks, guys.
Can't wait to see what we work on next. Jeff, that was a fun one. I mean, I know it's a simulated robotic arm, but it's not hard in your mind's eye to put that into the real world and see the implication. So very good, very cool work on the generative AI training front.
That NVIDIA software, it's almost like we always hear about the Unreal Engine for games, but that NVIDIA it's almost like a digital twin space where folks can do that. Now, that's kind of a little bit of a lift, to build like a digital twin like space of your robot and the table and stuff. But think about it, like how much time that can save once you get that done, and what you can do.
And I would imagine some of the patterns that you just saw might even apply in digital twin kind of domain. Like if you have digital twins that you're using and you want to learn from that using generative AI, there may be some crossover there. Jeff, I think that is all we have today. Did you learn something new?
Absolutely. I did. This was really cool. I wanted to go into robotics engineering, so that's why I was excited when Judith said that's what she used to do. Like in high school, that's what I was going to do. So I've kind of dabbled in it here and there, but so that was really cool and exciting to hear from her.
2 things I learned today. I should probably start learning Kubernetes a little bit more deeply. It sounds like it's getting easier. Maybe it's achieved that threshold where my small brain can handle it. And 2, robotics is really cool. And I'm going to keep my eye out for like the work that team is doing and some of the new stuff that we're doing with physical AI. I think we're going to hear a lot more this year about it. But
I mean,
Jeff,
we're going to be seeing robots in the Olympics pretty soon. So
that's true. Robotic long ski jumping. That'd be interesting. Hey, happy Valentine's Day, everybody, and thanks for joining us for another episode of AWS On Air. Until next time, we'll see you later. Ya.